Assalamualaikum warahmatullahi wabarakatuh. My name is Naila Zakia Malika. I'm taking Master in Computer Science in Management and Science University. My project title is Temperature and Humidity Monitoring for Poultry Farm using IOT. Chapter 1. According to statistics by Hisman, Malaysia consumes roughly 50 kg of chicken meat and 370 eggs every year. Malaysians prefer to consume chicken as the second most common meat, supplied by almost 3,000 poultry farmers in Malaysia. In the modern era, many Internet of Things technology that can help the work of people out. Many modern tools and devices that use the IoT concept to simplify working even at home using the IoT concept. This project will helping a small poultry farmer use the IoT concept to easy working and provide modern poultry farmers. Many of the small poultry farmers in Malaysia still using old technology in managing the poultry industry. Many traditional farmers cannot use advanced tools to manage the farms because of the high price. For the reason, the project is built to help small farmers to monitor and controlling poultry farm using IoT, Internet of Things. With this study, the farmer can monitor and controlling temperature of the chicken chop using temperature sensor to determine the temperature in the chicken cage and controlling the temperature of the chicken cage. Chapter 2. Small poultry farming is a new concept in poultry farming by utilizing advanced tools in digital and communication technology to improve poultry quality and productivity. This technology combines sensor, IoT, automation, and smart system. Automation of equipment in the shop will be precise because it's work based on data from sensor capture in real time. In a study, Ahmed Amar et al. Used a 4-step module and master module separated between the output system for activating the fan and the sensor. The master module consists of Arduino Mega 2560 and ESP8266 as a Wi-Fi module to connect the Arduino Mega 2560 master module and AT Mega 328 module as a microcontroller from DSC11, DSC22, LM35, and probe. Based on Elham et al. Study, I used DHC11 and Raspberry Pi 3 Model B as temperature and humidity measurement method. In implementing the system, the researcher aimed to build a smart poultry system based on IoT and blockchain technology to monitor the surrounding of poultry farm and securely store data. First, temperature and humidity monitor for preliminary research in area where proper temperature and humidity essential to the poultry operation performance. Chapter 3. The device we used in this project is ESP8266 as a microcontroller and Raspberry Pi 4 Model B to receive the data and transfer it to database. Also, sensor DHC22 will detect temperature and humidity level, then microcontroller ESP8266 will transfer the result of the sensor to Raspberry Pi. The temperature and humidity sensor DHC22, which follow the design of temperature and humidity to monitor system for user, the farmer. With a smart poultry farm using the Internet of Things IoT, the system programmed with a Python as the programming language to connect the DHC22 as the temperature and humidity sensor into microcontroller ESP8266 sensor. The DHC22 will detect the temperature and humidity level, and microcontroller ESP8266 will transfer the result of sensor reading through the router to Raspberry Pi 4 Model B. Process the data, and the output system fan and lamp will detect and turn on automatically if the environment overheat or too cold. The data result will transfer from Raspberry Pi Model B into the database through the router and received with MariaDB as a database implemented in the system to collect the result from the sensor. The actual diagram is represented by drawn a block diagram and provide an overview of the actual device used in the small poultry farm system to work. The module is divided into the slave module and master module. Slave module is component that consists of microcontroller ESP8266 and DHC22 as a temperature and humidity sensor. The master module is consists of Raspberry Pi microprocessor module B as a data processor and transfer data to a database as a server. Chapter 4. The picture a prototype device for the slave module that has been successfully installed. Slave module consists of DC22 temperature and humidity sensor, an ESP8266 microcontroller, and 2.0 USB cable. In this screen, the table of results from the sensor reading has been input the database from the DC22 sensor reading from ESP1 and ESP2. The data output displayed in the website is a due the temperature and humidity result. The system programmed with a Python as the programming language to connect the ST22 as the temperature and humidity sensor into microcontroller ESP8266. Sensor DST22 will detect temperature and humidity level, and microcontroller ESP8266 will transfer the result of sensor reading through the router to Raspberry Pi Model B, process the data. The data result will transfer from Raspberry Pi 4 Model B into the database through the router and received with a MariaDB as the database implemented into the system to collect the result from the sensor. Database is a need to collect the result from the ST22 sensor reading with the value of temperature T1, T2, and humidity H1, H2. In database display the result analysis of the smart poultry farm system when doing an experiment in the chicken cage with duration in a day. Each sensor in database has a different output in sensor reading. The temperature sensor has a temperature difference of 1 degree Celsius in different place. The indicator in temperature use Celsius as the calculation. In the humidity table, each sensor has 1 until 3% different humidity sensor in different place. The humidity calculation is done in terms of percentage of humidity in the chicken cage. The result will be input from MariaDB every 1 until 3 minutes into the database to be displayed on the website. The graph, the result of temperature level from the experiment that has been run and transferred into database. The researcher has been calculating it using graph to display result of DHC22 sensor reading every 3 until 4 seconds for an hour. Graph is needed to analyze the result from DHC22 sensor reading with the value of temperature T1, T2, and humidity H1, H2 in a graph display the analysis of the smart poultry farm system when doing an experiment in the chicken cage with duration in a day. Each sensor in the graph has a different output in sensor reading in the humidity table. Each sensor has 1 until 3% difference humidity result in different place. The humidity calculation is done in a term of the percentage of humidity in the chicken cage. The result will be input from MariaDB every 1 until 3 minutes into database to display on the website. The temperature sensor has a temperature difference of 1 degree Celsius in different places. The indicator in the temperature use Celsius as the calculation. Chapter 5. In this study, an IoT-based design was created to demonstrate how prototype and open-source software utilized to build an ESP8266, the purpose system for collecting the temperature and humidity in the chicken cage in poultry farm. This work has been accomplished with the assistance of Raspberry Pi and ESP8266 for controlling and monitoring. Real-time monitoring of environmental factor is critical. Environmental conditions necessary for the successful development of thickness have been found and described in this paper. With the result of this first investigation, farmer, researcher, and student can adjust environmental data inside the chicken cage. The frequency of recording is determined by the frequency with which data must be recorded. In the future, the system needs to add more environmental sensors to support the development of smart poultry farming systems such as CO2 value, rainfall value, and smartphone to control the evaporation system based on threshold value of temperature and humidity. Also, support the basic 3-layer of the IoT architecture to provide the security of storing data via cloud. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.